So we have the idea of a class. Class being a collection of data and the methods that act upon that data. Different books call the data different things. Fields, variables, all sorts of things. So we're broadly going to say that a class has members. The members can be variables. The members can be methods. Of those two things, you can have static and non-static members, meaning that you can have non-static variables, non-static methods, and the majority of yours will be these, even though we've been putting static on the methods inside of our main class. And then static variables and static methods. These are what are known as instance variables. These are instance methods, meaning that you have to have an instance of the class in order to use them. The scanner class, you can't call nextInt unless you have a scanner. These are called class variables and class methods, meaning that you don't have an instance of them. So examples. The scanner class has instance methods. So you have to create a scanner before you can use nextInt or whatever. The math class has class methods. So you don't have to create a math object before you use POW or square root or whatever. And in fact, this would not work. Math m is equal to new math. Error. It won't let you do that. Instead, you just go math, x is equal to math.absy, whatever. So in general, as long as the programmers you're working with have good naming conventions, which is to make all classes uppercase, initial letters, then you can tell if the method you're using or the variable that you're using is an instance method or a class method by, if you see this, glorpal.foo, very likely foo is an instance method. Excuse me, it's a class method. Why? Because glorpal started with an uppercase G, so we're going to assume it's a class. Whereas if we see oopy.bar, bar is an instance method because this doesn't start with an uppercase letter. Now, that only works if you make all your variables lowercase and all your classes uppercase. But this means that ABS is defined as static. Every class method is static. Every class member, every class variable. Every instance method or variable is defined as non-static. You just leave the keyword off. What does static really means? It means that that data is not stored in an instance of the class. So it is shared amongst all instances of the class. And as a matter of fact, you don't even have to have an instance at all, like the math class. The value of pi is defined inside the math class, but you don't have to create a math object in order to get to it. It exists outside of any object. So all the static members and static variables manipulate stuff that is not stored within an instance of the class. Why do we use that in our main class? Well, because the developers of Java, whoever invented it, said that the main method is static. And static methods can only call other static methods if they're in the same class. That is worth mentioning. Static methods can only call other static methods or variables if they are in the same class. You know, all bets are off if you're talking about stuff inside of other classes. Which is why, since main is static, all the other methods we may have been adding to main. So let's fire up your favorite editor. I wonder what some of these things are. Anyways, make a new project. Our rules generally should be that we put every class in its own file, but I'm going to break those so that we can fit them all in one place. I mean, on the screen. So I'm going to make a class called, I don't know, point. I don't like that. Let's make one called student. A student has a name. That's all we're going to put. And every student is going to the same school. Since they're all going to the same school, we're going to make that a static variable. So let's set that school equal to rows. Student.school, I should not have capitalized school. Excuse me. I'm going to go back and make that lowercase. Student.school is equal to rows. Now, student.name, this is an error by the way, so don't get too happy about typing it, is equal to Joe. Doesn't work. Why? This is a class variable. It applies to the class as a whole. This is an instance variable because it's non-static. We don't have an instance of it, so we can't change it. We have to make a student before we can start assigning instance variables values. We may as well put some comments. Static equals class variable. Non-static equals instance variable. Change the class variable. But we have to create a student. Student S1 equals new student. S1.name equals Joe. Now let's go back to the student class and add a toString method that'll turn that object into a string for easy printing. It better be a non-static method because we need to be printing stuff like name, and that's a non-static variable. So string, toString, we need to make a string and we need to return it. So string S is equal to string.format, and the syntax of string.format is the exact same as printf. So inside string.format, I'm going to say I'm a student, my school equals %s, my name equals %s, and then I'm going to actually fill in those variables. School, comma, name. Then I need to return that. Return S. Something's happening. It's saying that now that I'm trying to override toString, which is true, every single class already has a toString method because they all inherit from a superclass called object. It's saying you're making one with a lesser access level, so I'm going to make it public. This is what's called an override. Every class already has a toString method. That's how these things get converted to strings when you're trying to print them out. When you do that, if you're using NetBeans, you'll get a little warning. It's an incredibly petty little warning. It's just saying add an @override notation. You don't need that. It's just a comment. Some tools may, work a little bit better if they see that comment there, but we're never going to see a point where the code won't work without that comment. All right, now that we've created our student, given him a name, let's print him out. Student.out.println S1. That will invoke the toString method. And it printed out that the student's school was Rose and his name was Joe. And I made it badly formatted. There's no closing parentheses, so I ought to go back here and put a close parentheses there. In general, every class you make ought to have some kind of toString that prints some kind of debug information about it, just so that you can print something out and see what it is. Oh, student goes to Rose, name is Joe. So we're going to make a list of good ideas for classes. Guidelines for classes. 1. Every class in its own file. And your professor's already violated that. 2. The file name matches the class name. That's pretty much a must. But you can stick multiple classes in the same file. The class should be public. 4, if you are going to put extra classes in the same file, don't make them public. There can only be one public class per file. I think I'm going to take that out as being a point. I'm just going to do that. Comment on point 3. All right, and for those of y'all who have taken a basic Java course, we've already gone over these points that I'm going to do, which are, we want to make our data private, our methods public, and we want to put getters and setters for our variables. 7, add constructors if they make the class easy to use. 8, add a toString to make printing, debugging easier. All right, I really want you to memorize these. These are the super duper important ones. This is just kind of organizational stuff. Now, what do you, every class is in its own file. Yeah, sure. File name matches the class name. That's a must, as long as, at least one of them has to match. Make the class public. Yeah, great. If you're sticking extra classes in the same file, don't make them public. Yeah, that's a must. It won't compile otherwise. These are the important ones. So why don't we rearrange them so that this is 1, 2, 3, and 4, and this is 5, 6, and 7, or A, B, and C, or something like that. A, B, C, because those are kind of a qualitative difference than these. 1, 2, 3, 4, 5. This part, data private and methods public, is called encapsulation. It's putting the data inside a capsule. It's keeping the data safe from people who are using your class in their code from changing the data in ways that you don't expect. For example, you cannot access directly the data that's in a stack. Instead, you have to use these methods. You have to use .get or .pop or whatever in order to get it out. Somebody using that class, the stack class, cannot find a way of putting data into it in such a way that it would break those methods. Those methods should always work. The class has been debugged by people since 1995. It's probably going to work pretty well. The data is encapsulated. All the data has been made private, and then there are public methods in it that to access that data. You make a payroll class. You might make it so that if somebody tries to set a payroll to a negative amount, well, you earn $7 an hour. But I don't want to pay you to work here. You could forbid negative values. You could forbid values that are too high. You could check the access of the person who was trying to change that value, inside the code while it was running. You can make sure that your student object or your employee object or whatever has got data that is in a good state. And if any changes are made to it, they are all done via your methods. So you can do any validation that is required in order to make sure that it is still in a good state after they do that. So encapsulation is data private, methods public, so that you can validate data as it is added, changed, and make sure that someone using the class cannot change the data in such a way as to break your class. So really, this goofy little class here I put here with student is not a very good class, according to my rules. For one thing, he's sitting inside a file. He's not in his own file. What's another blatantly obvious mistake or incomplete? According to my 5 rules, what have I not done? Come on, guys, pull the 5 rules back up. Look at them, and you'll see some big differences between what I have up there.
Is it the getters and setters?
Yeah, I don't have getters and setters. They're not necessary because name is not private.
That's what I was about to say. Data's not private.
Data's not private, and the methods, the method is public. But okay. The reason I did that is because I was in a hurry to come down here and give you this example in the easiest form possible. But what we ought to do, and in my opinion, static variables, I don't care whether they're private or public or not. I'm just about, we'll leave it. Private static string school, private name, private string student ID. Now we need some getters and setters. This is always the most tedious part of it, but you can get NetBeans into doing a lot of this work for you if you really want. Are we all using NetBeans at the moment, or are you still using Eclipse at this moment?
I'm using Eclipse.
Well, I'm going to show everybody how to do it, and you're going to have to add them by hand unless you know how to make Eclipse do the same thing. What you do, if you want to make the tool implement getters and setters, is you highlight the variables. Fields is what NetBeans calls them. And then do refactor, encapsulate fields. It's got all the checkboxes. It's going to make getters and setters for everything. And then you do refactor, and presto changeo, it has added getters and setters for every variable. Cheap and easy way of doing it. I'm going to undo that, and we're going to do it by hand. We have 3 variables, so we need 3 getters and 3 setters. Do setters need to return a value, or can we define them as void?
I think you can define them as void.
We can define them as void unless we want the possibility of returning some kind of error code. We may as well make them void. And we may as well make them public. Public, void, set school, string, school name. I'm just going to do string S. School is equal to S. And I'm going to condense the formatting of this so that it just occupies one line. I did not use the this keyword, which I'm going to do on all of the other setters. Public void set name string name inside the parentheses this dot name equals name. Same thing for the student ID. Public void set student ID parentheses string student ID. I may put this one on its own line. It's going to go off the end of the page. This dot student ID equals student ID. Semicolon, close brace.
Yes, Eclipse can do the getters and setters, but it's under source, not refactor.
Okay, cool. It's been a little while since I used Eclipse, so I'm thankful for wisdom. All right, we have 3 setters. Now, what does the this keyword do? It differentiates whether the variable that follows it, the member that follows it, is a member of this class or just a local variable or parameter. In this case, student ID is a local parameter. There are no other kind of parameters. So to be able to distinguish between that one and that one, we say that this one is referring to a member of the object. Why don't we do that here? Why don't we do this dot school? Because, really? You're letting me do that? I am flabbergasted. You don't necessarily have an object to begin with. So I thought that you could not use this keyword. Well, if you're going to let me, and let's leave it alone for now. Okay, when I did that, it broke this stuff down here. We need to change student.school to student.setSchool. Because we made the variables private. They can no longer be changed like this. And student.name, we need to change that to student.setName. And pass Joe in. I seem to have made a mistake. I think I forgot to make setSchool static. Scroll back up and make setSchool static. Public static void. And now it's complaining about the this pointer. That is good. Why? Because if it's a static method, it's not referring to an instance. You don't have an instance to get a hold of, so you can't refer to this object. If you wanted to, you could do this, student.school. You know, you could preface it with the name of your class, but there's absolutely no need to do that. I guess I'll leave it like that. In that case, I could actually, you know, use this variable and call that one school rather than S. But I'm going to delete that. I never do it that way. Alrighty. Realistically speaking, toString ought to also print out the student ID. Right now, student ID will be null. So if we tack on one more %s to our format here, it'll print out a null. So we ought to at least give it a default value of some kind. student ID is equal to unknown. We could do the same for name. Name is equal to unknown. Let's change our string.format to include the student ID inside of the data. So ID is equal to %s. That's what I added right there. And then down here, comma, this dot student ID. And I'd really like to retroactively go back and put this dot in front of the name. Even when it's not necessary, I like to see that this is there because that reminds me exactly. Also helps typing. If you type, this dot, you instantly get a list of all the members of the class, all the variables and the methods. Save some typing. All right, so when we run it, it ought to say that the ID is unknown. Everybody at this point, or do I need to slow down?
I'm playing catch up for a second.
Okay, that's cool. Which part of the screen should I sit at?
I'm wondering why we were typing all the public voids when we did the getters and setters to create them.
Well, they need to be public.
Mine were created as public.
They weren't?
They were.
Okay. The reason why is, for one thing, in general, we want to make our methods public. We will talk about what the access levels mean. But you have this data, but you want other stuff to be able to get a hold of it. So the data is private. You need public methods in order to change it. Void, because the setters don't need to return anything. They're just changing something. We're not getting anything back out.
I think I'm caught up. What I was confused about is you were typing all the things, and mine were created automatically when I did the thing.
Right. So I'm sure yours look pretty similar, but they may have been fluffed out with comments and stuff like that. Yeah, they're the same. Yeah, we just rolled up our shoulders and did it the old way. You know how to do them if you had to, by hand. If you decide that you don't want the thing to be able to change the data, you can leave off the setter. I'm not thinking of a good example of that right now. But there may be times when the class has data inside it that is set in some way by some mechanism inside the class, and you don't want to allow the programmer to go in and call a set to change it. Like I said, I'm not coming up with a good example of that. If you don't want them to be able to get a hold of the data, you don't give them a getter. It may be some data that is absolutely of no use. I'm sure that this stack has all sorts of things in it that is no use to the programmer using the stack, in which case they probably did not provide getters for them. All right, we're getting close to having a well-designed class here. Notice, for you NetBeans users, and I'm curious if the Eclipse user has this warning out here on toString.
On public string to string, I have a override. It's giving me a message that's saying it overrides java.lang object to string.
Right. So there's a warning here on NetBeans. It wants us to add this. This is already getting into inheritance. Everything has a toString method, even if you didn't expect it to. So this overrides the implementation of toString. Just for grins, get rid of that override. Change the name of this to something temporarily bad, like put some underscores in front of it, and then run it, and watch what it prints out. When we tell it to print the student out, that's all we see. That's not real useful, but it's calling a toString method that is provided for the student class, even though we don't see toString. But all it does is give us the name of the class followed by the memory address of where that object is currently stored. And the name of this class is the package followed by the class name. Yeah, maybe that's useful, but I think it's much more useful to actually get the data out, so that's why we override. This little comment here is not necessary. It makes a warning go away if you add it. I'm always kind of curious as to why you even want it. Why use @override? Using @override is considered as best practice because it has two advantages. If the programmer makes any mistake, you will get a compile time error. And it improves the readability of the code. Okay, so it's not necessary. But if we made a mistake, like we said that we're going to override the toString method, but it's just kind of a sanity check. The compiler is going to go, no way, that doesn't work, because we're supposed to be overriding a method. So it's optional. All right, what else have we not done? We've done the getters and the setters, the data public, data private, methods public. We added a toString. Anything else? According to our list.
I don't remember what constructors are from last semester.
But it was on the list.
But it was on the
Okay.
list.
The idea behind a constructor is, down here, we accidentally didn't assign this object an ID. If we wanted to, we could do this. s1.set student ID, and we could give them an ID. 0, 1, 2, 3, 4, 5. Wouldn't it be nice, to quote the Beach Boys, S2 is equal to new student if we could do this? His name is Beatrice, and her number is 3, 4, 5, 6, 7. What gives us this ability is a constructor. Without the constructor, we can't pass data in between the parentheses. So that would make the class easier to use. And that's the way that I phrase the rule, is if it makes the class easier to use, you may as well provide a constructor. So we will do that. We will have to make some changes to the class to get it to work. If we were incredibly lazy, we would click on the error and tell NetBeans to fix it for us. But it wouldn't really fix it for us. It would just add the syntax to it that would make it compile. We're going to go fix it. A constructor, let's add this to our notes, is a method that has the same name as a class. No return value or type, doesn't return anything, and is invoked by the new keyword to create an object. And there was one more. Oh yeah, and can accept parameters to set variables. All right, I'm going to format this slightly better. A constructor is a method that has the same name as the class. No return type. You ought to make them public, unless you want to stop the programmer from using this as an object. That's how Java forbids you from making a math object, is they made the constructor private so that you couldn't invoke it. Get a compiler error if you try. So there's our 4 points. It's a method that has the same name as a class. It doesn't return anything, so you don't give it a return type. Is invoked by the new keyword. Can accept parameters to set variables. Let's add should be public if you want the code to be able to create new objects. Private if not. So let's go add a constructor. I like putting them near the top, maybe right underneath the variable declarations. Unlike some languages like C++, the order does not matter. We could put all these variable declarations down at the bottom or mixed in with the methods, but it looks pretty to put them here. Public, it has the same name as a class, student. It can accept parameters, so let's define some parameters. String name, student, string ID. This dot name is equal to name. This dot student ID is equal to ID. Now we have a constructor. Now if I scroll back down, hopefully that code actually works. I still see a red mark down here, so there's something wrong. I'm going to scroll down there and look. Oh,
It should be student ID instead of ID.
for consistency's sake, yes. In reality, this could be anything. We could call that Fred, because a variable name is just for our sake, not for the compiler. But student ID makes it consistent with everything else. Once we have done that, it breaks our code down to the south. Scroll down there and see what's wrong with it. See if you can take a guess as to why that is now broken. It gives you a warning. Or not a warning, it gives you an error message that may or may not be decipherable to the human eye.
It doesn't have any spots to put in the.
Right, we're not passing in any data. Well, I didn't have to before. That's because every class has what's known as a default method, a default constructor. Until you put your own in. Once you put in your own constructor, it gets rid of the default constructor. So if we still want the default constructor, we have to add it. Even if it doesn't do anything. Public, student, parentheses, in parentheses, don't do nothing. There. That stops the code from being broken. Now maybe we wanted the programmers to go and have to change all their code to use our new constructor, in which case you don't add a default constructor back to the code. Alrighty. How are we doing in compilers?
I'm good.
Good deal. To pause for a moment.
Go.
I have to go back and look at my notes and see if we've done this. Data private, methods public, getters and setters, add constructors if they make the class easier to use, add toString. So let's put a comment down here. Once you add your own parameterized, we're going to get all fancy with our language, constructor, which is just one that accepts parameters, Java stops providing a default constructor, one with nothing between the parentheses, one with no parameters. Add that back if you need to. I'm going to go ahead and make an assignment based on this idea. And these classes should pretty much all be review. But I'm not going to make this terribly long because we've already had a tree map assignment for this week. The homework is going to be write a class that follows all 5 of the rules up above. The class is car. The members are maker, company, model, year, don't want to go nuts, and mileage. Then use that class in a program to create at least 2 cars. You don't even have to allow data entry. We didn't on the student, so yeah, like that. Hopefully that's a short assignment and we have a very good example here, in my opinion. All right, but that's not really the end of the lesson. That's just where we're going to... Inheritance. Inheritance is the idea that, great, I have a class and it does some cool stuff, but now I want another class that does everything this class does and more. So maybe we're going to make a grad student class. And a grad student class does everything the student class does, but it adds an extra field, which is graduation date. The key word is extends. So class grad student or graduate extends the student class, but it has a new field, private grad date. Make it a string, is equal to unknown, or question mark, slash, question mark, slash, question mark, whatever, you know. We ought to provide some getters and setters for that, and we ought to provide a new toString, in my opinion. Why? Because we have some new data. So, to be cheap and lazy, use your program menu or your refactor menu. Refactor, encapsulate fields. Yeah, sure, go for it. It puts a whole bunch of JavaDoc comments, which I'm going to delete to try to keep as much on my screen as possible. And as a matter of fact, I'm going to kind of format it the way we did. And it put it above the data. I'm going to put it below it.
Did you just highlight the private string grad date or the entire class?
I just highlighted that string.
Okay.
I don't know how it works on Eclipse.
It's probably the same.
You could probably highlight the entire class and tell it to encapsulate the fields in that class. So we have that string. Highlight it, go refactor, encapsulate fields, and click OK. Refactor. And there it goes. It added our getter and our setters for that data.
That's what I was asking, because you had something where, I don't know why.
Oh, weird. What did you have to do, or did you go and type it by
I
hand?
just highlighted this.
Okay,
And
cool.
then went to
What is this?
source and then click setters.
I don't know why it's asking to do that. Don't. What is the error? Hover it over that. Introduce. Click it again. Hover over grad dates. Well, now it's gone. Give a mystery warning popping up. Okay. Okay, so let's forbid them from using the 2-variable constructor if it's a grad student, and then make a 3-variable constructor. So to do a 2-variable constructor that they cannot call, we're going to make it private. Private graduate, and it with 2 strings, name, string, student ID.
So you didn't set.
And we're not going to even make it do anything because we don't ever want them to use it. It's private. I put the semicolon in the wrong place. There we go. No, I did not. There we go. So, we did that so that nobody could create a graduate that only takes two names, two pieces of data. Instead, we want a constructor that will accept all three pieces of data. I'm a fan of being lazy. I'm going to go grab this constructor up here. You see that one? Grab that guy. And we're going to run into an error once we do this. Paste this, but change the name of the constructor to graduate. The error is that now these variables do not work. When it says private, it really means private. Only code in this class can access those variables, not even to the subclasses. So I need to change those from private to protected if I want the inheriting classes to be able to access them. So I'm going to change all these words private here to protected. Protected is the same as private, except for children classes can change, can get a hold of that data. So I had a constructor I was working on that accepts two parameters. I want to tack on the third one, which is grad date. String grad date. And down here we want to set this dot grad date equal to grad date. And just like we did by copying that constructor, go grab the toString method and pull it down there, except add an extra %s so that we can print out the grad date as well. So I'm going to grab Mr. toString here, copy him, come down here, paste him. I'm going to tack on one more %s, grad date equals %s, which means I have to add one more thing to my printout as well. So x, comma, this dot, grad date. It's always kind of up to you how crazy you want to go using the getters. Here we're using the variables. We could use the getters to access those variables, but we're not required to. We're in the same class. The getters are for the riffraff outside of this class to get a hold of that data.
Can you put this after each one of those instead of string format? 'Cause when it's working,
You don't have to put this.
it's working.
It is working
Yeah. It's been fun.
with or without the this is.
We've had the this is.
Yeah, that's correct. This is optional.
Oh.
It's always optional except in, man, this is an annoying word to talk about, har har. Here we had to use it. Why? Because we needed to differentiate between the parameter and the member variable. Down here, there are no parameters or local variables named name, ID, or grad date, so we could get away with leaving them off. So let's create a grad student, graduated student. Grad student G1 equals new grad student. We have to provide three pieces of information. Bob, student ID 78901. He's going to graduate this summer, 6/1/2017. And I've done something horrendous. Why is it not compiling?
Say graduate instead of grad student.
Yeah.
Okay, graduate. And let's print him out. System.outline, system.out.println, G1. We didn't print out student S2, so I'm going to print them out as well. System.out.println, S2. All right, the syntax of the debug print looks kind of lousy, but we can see it's got both a name and a school and an ID and a graduate, a grad date. So this class here, graduate, gets all the abilities of this one plus more. It gets the static variable, it gets these other pieces of data, it gets the methods that act upon that data, the getters and the setters and so on. So you use inheritance when you want to make a class that has all the abilities of another class but more. The class you inherit from is called the superclass, which makes it sound awesome. Ooh, student is my superclass. But it's not. Really, graduate has more powers, right? It has extra methods that student did not. So don't be tricked by the word superclass. Other textbooks call it the parent class. I kind of like that better. The parent class is student, and the child class of that parent class is graduate. So a couple more notes. What is the inheritance keyword?
Extends.
Extends. Superclass is the class you extend from. Subclass, that's a bad way to put it. Let's just write this. Subclass extends superclass. Hope that makes sense. In our example, student is a superclass, and graduate is the subclass. All right, let's stop there.
I have a question.
Yes, sir.
My graduate G1 with new graduate stuff isn't working. That one. Where I typed in.
Sure.
Typed in, I don't know.
Maybe because we didn't get the constructor in. I'll come look.
Mine works.
All right, hover your mouse over the error. It may say not enough items. Wow. Okay, scroll back up. Graduate wound up being a member of the student class. So cut all of this stuff, or just move that and close brace, right. It's weird that you can embed classes within classes, but you can. Yeah.
The whole graduate thing was inside the student.
Yeah, you can define one class inside of another class, inside of another class if you want.
It is.
How's yours going?
Oh, mine's good.
All right,
Till Jerry fixed it.
let's make a Dropbox.